Okay, this is a question on parametric equations. Okay, the first thing we've got to do is find the coordinates of the point on the curve when t equals a half. So for the coordinates of a point, I need an x and I need a y, and I've got an equation for x in terms of t, I've got an equation for y in terms of t, so I put a half into each one, I get a value for x, a value of y, I write the answer as coordinates, and that should be 2 easy marks for putting the answer as coordinates. Then for part B, I've got to show that these parametric equations are equivalent to this. Okay, now because they give me this, it is actually legitimate to take my x and multiply it by the y and get what xy is in terms of t, and square y and get that in terms of t, and do a subtraction. And if I can convincingly show that the answer to that is 2, then I can say that I have shown that these equations are equivalent to this one. Okay, then in part C, I've got to do a gradient of the curve at the point 3, 2. So I've got an x value, I've got a y value. Okay, gradient is going to be dy by dx, but for parametrics, to get dy by dx, I need to start with dx by dt. Well, here's what x is, so you can get dx by dt, and similarly, you can get dy by dt. We know that to get dy by dx, we need to do dy by dt divided by dx by dt, and that will give me an expression for the gradient, but that will come out in terms of t. So the next thing I need to do is decide, okay, I've got an x, I've got a y, I can use either one of these. This is probably the easier one. I know that y is 1 over t, but I also know that y is 2, so that's going to enable me to come up with a t value, which I can substitute into my dy by dx. Okay, and when I do that, then it should come out to give an answer of 2, and I can say that I found the gradient is 2.